Hello guys, welcome to Know Your Goal. Today we have a lesson and the lesson will be about mathematics. So mathematics lesson will be given by Mr. Makari. So get a pen and a paper to take some notes. Watch out.
Record the lana functions. This part is going to cover grade 11 and grade 12. Grade 12 is going to be a revision. Now, first of all, we have to talk what is a function. And a function is a relationship between x and y. That is the relationship between x and y. It's a relationship between x and y. Our x is going to be our domain, and our y is going to be our range. Now, whenever we're talking about the domain, we're talking about the x values, and the range is y values. And also, a domain is our input, is our input, and range is our output. Now, that is where we're going to talk about a function as a relationship between x and y. So guys, we are going to focus on 4 types of graphs. We have 4 types of graph. We have 4 types of graph. Now, we have number 1, which is our straight line. We have a straight line. And our straight line is given by what? Our straight line is given by y equal to mx plus c. Y equal to mx plus c. Where m is the gradient. Where m is the gradient. That is the gradient of what? Of our graph. And that the very same gradient can be positive or it can be negative. The gradient can be positive or negative. That is our gradient. Where our c is the y-intercept. That is the y-intercept. That is straight line. A straight line is a very simple graph. Sometimes it might be given in the form of ax plus c. It's still the straight line. Now, the gradient, whenever the gradient is positive, that's when we talk about the Cartesian plane. A Cartesian plane is given by positive x, positive y, negative x, negative y. Now, if ever you can check from our first quadrant, we know that this is positive and the other one is positive. The positive times positive is positive. And also in our second quadrant, we have the positive and the negative. Therefore, positive times negative is going to be negative. Now, on our third quadrant, we have negative and negative. The product is positive. Now, on our fourth quadrant, we have the negative times positive. Then it's going to be negative. Now, whenever we're saying that the gradient is going to be positive or negative, we are simply saying that this line is going to lie, whenever the gradient is positive, it's going to lie on our first quadrant and our third quadrant. It doesn't matter where, as long as we see that it is lying on our first quadrant and our what? And our third quadrant. Are we together, guys? Alright. Whenever a gradient is negative, then this line or this straight line, it is going to lie on our second quadrant and fourth quadrant. This is our second quadrant and our fourth quadrant. Now, this one is showing that the gradient is negative. That is what is lying on the what? On the second quadrant and fourth quadrant. Alright. A straight line is a very simple graph. The only thing that you have to know is that M represents the gradient, C is the y-hat or y-intercept. Alright, our second graph is going to be parabola. It's going to be parabola. Now, parabola, it has three equations. Parabola is given by y, which is equal to ax squared plus bx plus c. That is equation number 1. This one represents parabola. And number 2, our y equal to a into x minus p all squared plus q. And also this one represents parabola. The third one is going to be y equal to a into x minus x1, x minus x2. On this one, sometimes in different books you may find that x1 is given by r1 and x2 is given by r2. This one is simply mean we're talking about the roots of x. Actually, this one, we normally use this equation whenever we want to find the equation of a parabola, provided that you are given the roots of x. Okay, we're going to talk about the axis of symmetry. So the axis of symmetry, mostly they ask you about the equation of axis of what? Of symmetry. Now, what is axis of symmetry? Axis of symmetry is a line that cuts graph into two equal halves. That you have to know about the axis of symmetry. Now, let's take for example, you are given the equation in the form of y equal to ax squared plus bx plus c. In order for you to find the axis of symmetry in this equation, you say x equal to minus b over 2a. If ever you can check from this formula, our b is the coefficient of x and our a is the coefficient of x squared. Now, that is how you find the equation of axis of symmetry. Let's take for example, you are given y equal to x squared minus x minus 6. Now, then you have x equal to minus b over 2a. Which equal to, if ever you can check, the coefficient of x squared now is 1. The coefficient of x now is negative 1. Therefore, we're going to say negative is from that formula. Then our b is negative 1 over 2 into the a is the coefficient of x squared. Now the coefficient of x squared is 1, which equal to x equal to negative times negative is going to give you positive 1. Over 2 times 1 is 2. Now, this is how you find the equation of axis of symmetry. Provided that your graph is in the form of this. This is how you find the equation of what? Of axis of symmetry. Let's talk about the axis of symmetry whenever the equation is in the form of y equal to 2 into x minus 1 squared plus 3. If ever you can check this equation, that is equation number 2 from that one. Our a is 2, our p is 1, our q is 3. Now, you need to find the equation of axis of symmetry in the form of this. How do you do it? Now, just say x minus 1 equal to 0. Then x equal to negative 1 to the other side is going to be positive. Then it's going to be x equal to 1. If ever you can check this equation, it's in the form of this. How do you find the equation of axis of symmetry? You just take this part, which is inside the bracket, then you say x minus 1, then you equate it to 0. In other words, in order for us to find the axis of symmetry, provided that this equation is given in the form of that, we solve. We just solve. This is how we solve. X minus 1 equal to 0, then x equal to 1. Okay guys, let us move to the turning point. These are the basics that you have to know about parabola. This is the basics that you have to know about parabola. Let's talk about the turning point. Number 2. This is very important also. The turning point. The turning point. The turning point of a graph. The turning point is where you can find the maximum value, and that is where you can find the minimum what? Value of that graph. Now, the graph, it needs to turn. Are we together, guys? Before it hits the what? The y-intercept. Now, the turning point, let's say you're given y equal to ax squared plus bx plus c. And they say, find the turning point of this graph. Remember, this graph is in the form of that number 1. Okay. You need to find the x value, and the x value equal to minus b over 2a. Just because our turning point, it is given in the form of x and y. So, we need to find the x value of the turning point. Remember, the very same x value of the x of symmetry, it is the x value of the turning point. That is why we are repeating this formula. Now, x is going to be minus b over 2a. Then, after finding x equal to minus b over 2a, then you are left in order to find the value of y value. How do you find the y value? Whenever you have value x, by substitute a graph yeba e1 ya original, or whenever one meaning a y value. Now, then you substitute the x value into the original graph. You substitute the x value into the original graph. The original graph will be the graph that is going to be examined. That will be the original what? Graph. Then after substituting the x value into the original graph, you find the what? The y value. Therefore, your turning point is going to be in the form of x and y. This is how you find the turning point. Okay guys. Let us take the example of this turning point. Let us say you are given the very same graph, which is f(x), which equal to x squared minus x minus 6. You are given that graph in the form of this, and they say determine the turning point of that graph. Now, you have to say x equal to minus b over 2a, which equal to. Then you say negative into, then you take the coefficient of x is b, is going to be negative 1, divided by 2. Your a is the coefficient of x squared, which is 1. Then the answer is going to be 1 over 2. Now, you are left to find the y value. How do you find the y value? You substitute the x value into the original graph in order to find the y value. Okay guys, let us substitute. Then f into 1 over 2, which equal to, whenever there is x on the original graph, you put 1 over 2, which is 1 over 2 squared minus 1 over 2 minus 6. Now 1 over 2 squared minus 1 over 2 minus 6. It's going to be negative 25 over 4. Negative 25 over 4. That is your y value. Therefore, your turning point is going to be 1 over 2, that is the x value, and your y value is going to be negative 25 over 4. Are we together, guys? This is how you find the turning point, provided that your graph is in the form of this. How about the graph whenever it's in the form of this? Graph number 2. Still, it has the turning point. This graph has to turn. Now, the turning point of that graph is given by x and y, that you have to remember. And you know that it is given by y equal to a into x minus p squared plus q. What is it that you have to know? You solve. The x value is going to be x minus p, which equal to 0. X minus p equal to 0. Therefore, our x equal to p. That is the value of x to that what? Turning point. You solve. Well, how about the y1? Then y is going to be q. We just take. The q1 we just take. If only the graph is in the form of this. We just take together with the side. Now, the turning point is going to be, the TP is going to be, our x value now is P, and our y value is Q. That is how you find the turning point, provided that the graph is in the form of this one. Are we together, guys? Now, another thing that you have to remember, before I can move any further, let me take an example, provided that graph is in the form of this. Let's say you have g at x. Remember, f at x, g at x, h at x represent y values. Now, that is the naming of the graph. Then g at x equal to, let's say x minus 2 squared plus 1. You are given x minus 2 squared plus 1, and they say determine the turning point of that graph. Now, the turning point of that graph is going to be x minus 2 equal to 0, x equal to 2. Then you take this negative 2 to the other side. Then it changes the sign. The negative becomes positive. The positive becomes the negative. Now, then x equal to 2. The y1 we just take. Then with the sign, that is positive 1. Therefore, the turning point to that equation is going to be 2 and 1. The thing is very simple, guys. Okay. Now, let us move further. You must always remember that each and every graph has the x-intercept and y-intercept. Each and every graph has intercept, irrespective either is straight line, parabola, hyperbola, and exponential. But you must always remember, each and every graph has x-intercept and y-intercept. Okay, the shiftness of the graph. When we talk about the shiftness of the graph, we are saying that the graph can shift either to the left or to the right, or the graph can shift up or down. Now, when we talk about the shiftness of the graph, let's say if P is greater than 0, talk about the shiftness of the graph. If P is greater than 0 simply means positive. Now, if P is greater than 0, the graph will shift to the left. You must always remember that. If P is greater than 0 means positive, the graph will shift to the left. And also if P is less than 0, the graph will shift to the right. Less than 0 simply means negative. Whenever P is negative, therefore the graph will shift to the right. Whenever P is positive, the graph will move to the left. We don't know the units. Let's say, for example, let's say the graph shifts 2 units to the right. So which means, if ever, let's say for example, you have this graph. They say this graph shifts 2 units to the right. So which means, you are going to have g at x, which equal to x minus 2, from x minus 2, and they said to the right. So which means, it simply means that 2 is going to be negative just because it's less than 0. Therefore, it's going to be negative 2 squared plus 1. Then your graph is going to be x minus 4 squared plus 1. So which means you can see now that this graph shifted 2 units to the right. That is why now you have x minus 4 all squared plus 1. Okay, without any wasting of the time, let's talk about if Q is greater than 0. Now, the graph can shift left or right, or the graph can shift up or down to that Cartesian plane. If Q is greater than 0, then the graph will shift upwards. The graph will shift upward. So which means our Q is greater than what? Our Q is greater than 0. The graph will shift upwards. We just don't know how many units, but it will move what? Upwards. Only if Q is positive. Greater than 0 simply means positive. And also if Q is less than 0, the graph will shift downwards. If Q is less than 0, therefore the graph will shift downwards. So less than 0 means negative. Now, what you have to know about parabola, the last one you have to know about parabola is the effect of A. You can see that we have A from these equations of parabola, or from the previous equation that I gave you. You can see that we have our A there. You can see you have A in each and every equation of parabola. Y equal to A into x minus x1, x minus x2. You can see you have the value of A. Now you need to know the importance of that value of A. Now our A determines the shape of the graph. The shape of the graph. How the shape of the graph will be, that A determines the shape of the graph. And remember, our A can be positive or can be negative. That you have to know about parabola. Now, our A can be positive and A can be negative. What is it that happens when A is positive or when A is greater than 0? Let us use when A is greater than 0, but it's the same, we're saying positive. When A is greater than 0, the graph is going to be like this. The graph is going to be like that. That is when our A is greater than 0. If ever you can see, that graph is going to be like that. That is the shape of the graph. That is when A is greater than what? Than 0. When A is less than 0, the shape of that graph is going to be like this. That is the shape of the graph. When A is less than 0, this graph is going to be like this. But when A is greater than 0, the graph is going to be like that one. You are given y equal to ax squared plus bx plus c. And they can say, write this in the form of y equal to a into x minus p squared plus q. If ever you find a question that says, write this one in the form of that one, you must always remember that there's not any other way that you can solve that one unless we complete the sphere. Unless we complete the sphere. Let us take for example, we have AG, which is y equal to 2x squared minus x minus 6. And they say write this in the form of y equal to a into x minus b squared plus q. If ever you can see, if ever you can check this part, you ought to have our a, and your a is that one. You come to this equation and say y equal to, then you take out a as a common factor, then you take out a as 2, then you open the brackets, and you say, you know the number that you can multiply it with 2 and get x squared. That one is going to be x squared. And also, from this one, you need a number in which you can multiply it with 2 and get negative 1. If ever you can see, this is very simple. You multiply these 2 by the multiplicative inverse of 2, which is 1 over 2. Then it's going to be negative 1 over 2x. This is how you do it. In order for you to find the one that you multiply it with it, you get negative 1. You use the multiplicative inverse of that 2, which is 1 over 2. Just that there's negative, you introduce that negative. Alright. The negative is that negative. You say you need a number that you can multiply it with 2 and get 6. That is 3. You have something like this. This is your a, remember? Then you have 2, then square brackets, then you are going to complete the square from this one. You know that complete the square say that we add the half of the middle term and you square it. Then you are going to have negative 1 over 2x. You add the half of negative 1 over 2, which is negative 1 over 4 squared. You square it. Then you have negative theta squared. When we complete the square, it's going to be x squared minus 1 over 2x. Then we add the half of the middle term together with the sign, and we square it. After adding it, this is negative 3, and this is negative 3. Then after adding the half of the middle term, you subtract it, the half of the middle term. Then after that, you have 2, the square brackets. This part is very simple, you don't have to reason any further. Then you have squared. Inside the brackets, you must always remember, this is the perfect, the complete sphere. Now, inside the brackets, you are going to have x. Don't panic in which you have to write inside the brackets. Inside the brackets, always you must write x and the half of a middle term together with the sign. So if ever you can check here, the half of the middle term is going to be negative 1 over 4 together with the sign. Then we come to this side. You move your calculator this side. If ever you can move your calculator, it's going to be negative 49 over 16. If ever you can verify it with your calculators. But if ever you move into the calculator, you're going to have something like that. Then, to the final answer, you say, we're going to remove the square brackets. How do you remove the square brackets? You multiply by 2. Then, this 2 is going to multiply the whole of this. Then you are going to have 2 multiply x minus 1 over 4 squared. Then you say 2 multiply by this, 49 over 16. It is going to be negative 49 over 8. Altogether. It is going to be negative 49 over 8. Now, if ever you can check this answer. Now, this answer now is in the form of this. Where is A? A is your 2, P is there, squared is there, Q is negative 49 over 8. This is how you complete the square of the graph. They say write this one in the form of this. This is how you do it. Okay guys, let us move to the graph, to the third graph. Let us move to the third graph. These graphs are very simple. Now, okay, let us move to this graph which is called exponential. Exponential. We have the exponential graph. Whenever you're dealing with the exponential graph, you have to remember about the exponential laws. Alright, when we talk about the exponential graph we find it in the form of A times B, x plus P plus Q. That is how you find exponential graph. It is called exponential just because the independent variable, which is x, it is in the exponent. That is why it's called the exponential graph. Now, y equal to a multiplied by b to the exponent x plus p plus q. The effect of p and q, I explained that. I said that the effect of p, it shifts the graph either to the left or to the right. And the effect of q, I told you that it shifts the graph up or down. Now, our A determines the shape of the graph. It's still the same. But what is it that you have to know about the exponential graph? The only thing that you have to know is about the horizontal asymptote. It has the horizontal asymptote. It has the horizontal asymptote. What is an asymptote? Asymptote is a line at which the graph will go closer to it, very closer to it, but it will never touch it. That is asymptote. Asymptote. Now, if ever they talk about the horizontal asymptote, they say horizontal asymptote is the same as they will ask you about the equation, because it is given in the form of what? Of equation. That is horizontal what? Asymptote. Now, the horizontal asymptote in exponential graph is going to be y equal to q. It's going to be y equal to q. It's going to be that one. Y equal to q. You take even the sign. Y equal to q. That is the horizontal what? Asymptote. Now, the horizontal asymptote is a line into which the graph will go closer to it, but it will never touch it. Let's take for example, HE. Let's say given y equal to 2 the exponent x minus 1. And they say, determine the equation of asymptote. Now, the equation of asymptote to this problem is going to be very simple. You just take y is going to be negative 1. You take that q together with the sign. And the sign now is negative. Therefore, y equal to negative 1. Very simple. Now, let us move further to the exponential graph. Now, number 2. I told you that the graph, it has to have x and y intercept. Even exponential graph, it has x and y intercept. Now, let's talk about the reflection. The reflection of that graph. Now, when we talk about the reflection of the graph, we're talking about the mirror image of that graph. Now, just because the graph, whenever we talk about the graph, we're talking about the x and y axis. Now, this graph is going to reflect with respect to x-axis and with respect to y-axis. Now, that is why we talk about the reflection of the graph. The reflection of the graph doesn't mean the graph is going to change the shape. No, the graph is just going to reflect. Okay. Now, reflection, I'm going to write with respect to. WRT simply means with respect to x-axis and also with respect to y-axis. That graph is going to reflect with respect to x-axis and together with respect to y-axis. Now, when we talk about the reflection of this graph, we are just going to introduce negative. We only introduce negative. But the difference it is where do we put that negative? If the graph is reflecting with respect to x-axis and also with respect to y-axis, where do we put that negative? Now, okay, the reflection with respect to x-axis, Now that graph is going to be y equal to, we introduce negative to that graph. You see, it's going to be a multiplied by b to the exponent x plus p plus q. We introduce the negative. This is the graph, you introduce the negative. When y equal to minus into a multiplied by b, x plus p plus q. Now, this is the whole of this graph. When do we introduce the negative? Here. We just introduce the negative, then we copy that graph. That is the reflection with respect to x-axis. What about with respect to y-axis? And also here, the graph with respect to x-axis and the reflection with respect to y-axis. Now, okay, reintroduce a negative. Now, that negative depends on where are you going to introduce it. But only the keyword here is x-axis. Whenever they say the reflection with respect to x-axis, so which means whenever we talk about the reflection with respect to y-axis, then it's going to be y equal to, we introduce the negative. But in this case, we're going to introduce negative to that negative x plus p. Then for example, let us say you have given g at x which equal to the exponent x minus 1. And the question can come and say sketch the graph. Guys, whenever you sketch the graph, you must always remember that you need to have the asymptote. But the asymptote, it needs to be in the form of equation. Therefore, the asymptote is going to be y equal to negative 1. That is the equation of what? Of asymptote. Now, number B. Let's say you determine the x-intercept and the y-intercept. You must always remember that x-intercept y equal to 0. X-intercept y equal to 0. Therefore, 2 to the exponent x minus 1 equal to 0. Then we'll take negative 1 to the other side. It's going to be 2 to the exponent x equal to 1. In this case, as I told you that this is exponential graph, you must always remember about the exponent laws. Now we're going to use law number 7. That says that 2 to the exponent x equal to any number to the exponent 0 is 1. We are just changing this one to the base of 2 so that we have the same basis. If ever, the laws of exponents say that if ever the bases are the same, when we have equal sign, we equate what? The exponent. Therefore, x equal to 0. That is how we equate what? The exponent. Guys, you must always remember. I'm going to write this one. 2 to the exponent x equal to 0. You find that the equation is given to x equal to 0. Guys, never and ever attempt to write 2 to the exponent x equal to 2 to the positive. This one is incorrect. If ever 2 to the exponent x equal to 0, only if equal to 0, therefore you don't have a solution. It's undefined altogether, guys. Now, this law only apply whenever we have 1, just because any number of the exponent 0 is what? Is 1. Now, we have x-intercept and also we have y-intercept. The y-intercept x equal to 0. When we talk about the y-intercept, we are saying the x equal to 0. Now, therefore, g at 0, 2 to the exponent 0 minus 1. Any number to the power 0 is what? Is 1. Minus 1. 1 minus 1 is what? Is not. Therefore, that is your y-intercept. Y equal to 0. Now guys, we need to sketch this graph. This is how you need to sketch this graph. This is your x, this is your y. First thing first, that you have to check. This is the asymptote. The asymptote now is negative 1. If ever you can check, this is positive y, negative x, negative y, positive x. Now, y equal to negative 1. So which means the asymptote is in this position. Therefore, it's y equal to minus 1. Remember, this graph is not drawn according to a scale. That is why we just have to name that y equal to negative 1. You check whether you have x and y intercept. The x-intercept is 0 and 0, therefore 0 and 0 is here. And the y-intercept is 0 and 0. Therefore, this graph is going to be like this. Then it has to go to the asymptote, but it will never touch the asymptote. That is how you draw the graph of exponential. This is the shape of exponential graph. Are we together, guys? Let us say they ask you to determine the reflection of this graph with respect to x-axis. Let's say this graph is reflecting with respect to x-axis. The very same graph with respect to x-axis, I told you that we introduce the negative. But where? If ever is x-axis, it's going to be negative. Open brackets, x minus 1. If ever you take out the brackets, it's going to be negative 2 exponent x. Negative times negative is going to be positive 1. This is the graph of reflection with respect to x-axis. What about with respect to y-axis? If ever they ask you the reflection with respect to y-axis of this graph, we are going to introduce negative. There is going to be 2 to the exponent negative x, the negative 1. We don't have to change this one. Only introduce negative to that exponent of x. This is how we did about exponential graph. Are we together, guys? Now, let us move to the last graph. Guys, these graphs are very simple, very simple. Now, let us move to this graph. This graph is called hyperbola graph. This is hyperbola graph. Hyperbola graph. Hyperbola graph. This is hyperbola graph. We're going to talk about hyperbola graph. Guys, you must always remember each and every graph, I'm repeating, each and every graph has x and y intercept. You must keep that in mind. Now, when we talk about hyperbola, we are going to talk about y equal to a over x minus p plus q. Hyperbola graph, y equal to a over x minus p plus q. This is hyperbola graph. Now, in this case, A determine the position. Now, in this graph, we only talk about the position of the graph. A determine the position of the graph. Now, what do we mean about the position? If A is greater than 0, then the graph is going to lie on the first quadrant and the third quadrant. If your A is greater than 0, then the graph is going to lie on the first quadrant and the third quadrant. That is the position of the graph. And if A is less than 0, then the graph is going to lie on the second quadrant, just like that, and the fourth quadrant. This is how you determine the position of the graph. Now, A determine the position of what? Of the graph. Okay, guys. This is the only graph that has 2 asymptotes. Okay, we're going to talk about the asymptotes of this graph. Asymptote, as I told you, is a line at which the graph will go closer to it, but it will never touch it. That is asymptotes, guys. Now, whenever they talk about the asymptotes in hyperbola, they either ask you about the equations. They can say determine the equations of asymptotes, or else determine the coordinates, or the coordinates of asymptotes. We have the equations of asymptotes, we also have the coordinates of asymptotes. Equations of asymptotes is going to be x minus p equal to 0, that one we solve. Then x equal to p. Equation simply mean equal to. That is why we have x equal to p. That is equation number 1.
Okay guys, I hope you enjoyed the lesson. Stay connected with us on YouTube channel and never for our new project. Thank you. See you next time. Ta-da.